Hi, Thomas Holden here, Technical Manager at Roadstone. We're here today in the Concrete Research and Development Lab, and with me is Marchant, and we're here today to discuss the need that Marchant saw the use of mass-produced truck-delivered concrete for 3D printing.
From our perspective, using 3D construction printing in a very traditional market, it's new technology, and what we wanted to do is bring it back to what the industry understands, to existing technology that's tried and tested and that the industry trusts. One of the ways to do that is to print traditional concrete that's delivered through one of the most prominent delivery methods, which is ready-mix concrete. And that allowed us to produce EN206 compliant material, which you guys have a very rigorous factory production control procedure on, and just basically deliver material that the industry knows and that they're familiar with working with.
What were the other producers or other printers using?
Mostly it's mortars. So the industry uses a sub 4 millimeter AG, and they have a mortar with very high binder contents. So for us to be able to transition to a standard concrete, it means we can substantially drop our binder content, which has cost considerations. It's a lot cheaper because cement's probably one of the most expensive elements. And there's a very big carbon benefit to reducing the amount of cement that we have in our materials. So I think the material that we've developed globally is one of the lowest carbon embodied materials. We've got a binder content of 360 kilograms per cubic meter, which I'd say is definitely towards the lower end of what you'll see globally for printable mixtures.
Because we're using concrete.
Exactly. And we've got the larger aggregates, and we need a lesser paste volume fraction. So there's physically less area to coat. When you're mass casting, when you're looking for scale, it is the more robust and versatile material to use. Getting the AG in and actually using concrete allowed us to drop the cement. Exactly. And I think where it also originates from is if we've got this code compliant material, it's EN206 compliant. What that unlocked for us as a printer manufacturer of houses is we can use traditional Eurocode norms. So we can use Eurocode 6, which is basically our block equivalent to our masonry standard, to design the buildings that we 3D print. In terms of what this means for us in this new emerging market is we've got code compliant materials and we've got code compliant designs. So from a scaling perspective, again, we're going back to what the industry knows. We're going back to what people understand, what our wider design team understands, and we're delivering new technology to solve an issue that we have, housing.
So market acceptance will be much quicker.
Exactly, that's what it is. It's all about what was the most efficient, fastest route to market. We have a massive housing shortage, and we want to solve this problem. And for us with new technology, we want to penetrate that market as efficiently and as fast as possible. So going with existing standards, so codified materials, codified design methodologies, that's what the market knows.
A lot easier, quicker for acceptance of this modern method of construction, which is printed concrete.
Exactly. And the thing is, we can leverage the experience of Roadstone, of master builders, the admix providers, which has this wealth of knowledge and experience in delivering and producing concretes.
If we were producing a mortar, you can imagine being out on site with an engineer having to explain the properties of the mortar. When we're using 37 Newton concrete, that's just a given. It's 37 Newton concrete. Yeah. It complies with EN206. It makes the whole process much simpler on the explanation to an engineer or architect of what material we are using.
Exactly.